Hello, my name is Alan Smith and I'm proud to represent DROPS and equally proud to be sharing this short presentation with all participants of the LIA Global Lifting Awareness Day. I have a short video to share focusing on industry's common problem of dropped objects and more importantly, how our common goal of dropped object prevention can be achieved through a common approach. Our exposure to dropped object potential within the oil and gas sector, in particular upstream drilling and well services, is across all activities throughout the full supply chain. It is a dynamic working environment with operations that require heavy equipment to be suspended and maintained at height, continuously exposed to significant cyclic forces from many sources. There are also many supporting activities, such as lifting, transportation, stacking, storing, and the ongoing inspection, repair, and maintenance whilst working at height. For over 20 years, the oil and gas sector has been learning and sharing lessons from incidents through DROPS, the Dropped Object Prevention Scheme. It is a member-funded initiative which includes representation from operators, major service partners, and a broad cross-section of the engineering and inspection contractor sector, plus a number of specialist product suppliers promoting best practice in securing tools and equipment at height. DROPS now boasts over 200 members globally. The main objectives are to eliminate the potential for personnel injury, to eliminate the damage sustained to assets and equipment, to eliminate the damage to our environment and to business. The ultimate goal is to offer a resource that promotes a second nature prevention strategy, where we all form instinctive and habitual approaches to identifying, assessing, and managing dropped object potential in every task and in every step. First, we must acknowledge that there is a problem and that dropped objects do pose a significant threat to the business. Data from various sources confirms that dropped objects do continue to harm and kill personnel and members of the public. Typically, we learn from the unfortunate consequences of incidents. But once there has been an unplanned release of gravity's constant acceleration factor, there will always be a consequence based on the item's mass and the distance it falls. Equipment damage can result in unnecessary loss and repairs, or loss of containment that results in spills or unnecessary waste. Ultimately, a dropped object incident will always cause damage to the business through lost time, lost money, and reputation damage. In studying dropped object incidents during lifting, there are many examples that can be described as failures in load securement. These fan tubes were being lifted in an open tray. The crane operator was very lucky that day. Equally, there are incidents that relate to lifting and lifting equipment and illustrate that dropped objects can occur anywhere and at any time. After all, lifting equipment and ancillary fixings are subjected to continuous loading from lifting activities and the working environment. Cranes require maintenance at height, so tools can be dropped. And there's always surprises, from dropped level indicators, balls of congealed grease, and even nuts and bolts that secure individual items to the structure. But when using DROPS tools, such as the consequence calculator, it is apparent that even the smallest of items that fall from height can cause harm. In this example, if a 200-gram bolt was to be dropped over 30 meters, a life-changing major injury would be very likely. All incidents will have underlying causal factors, and investigations will highlight areas for improvement. Well, these common causes of dropped objects can also be considered as prompts to inform task planning and risk assessments. When it comes to dropped objects during lifting, incidents show that almost all of these common factors are likely to prevail at the worksite. Human factors, or the range of physical, psychological, social, organizational influences which can affect how people carry out tasks, can also be considered as error traps, or the factors and situations that cause people to make mistakes. This is an area of focus that many industries have explored and addressed. These common causes also inform the continued development and improvement of shared industry guidance. Although IOGP is the voice of the oil and gas sector, their recommended practice for lifting and hoisting safety is readily adaptable and includes a number of useful templates. Perhaps more importantly, it addresses safety management system elements, emphasizing that there are essential principles for every activity in every task. The guidance for categorizing lifts and developing specific lift plans is certainly an opportunity to address this in detail. Other industry resources, such as HPOG, the Human Performance Oil and Gas, presents adaptations of shared best practice in identifying and managing the factors that influence people and how they respond and work. But for drops, a comprehensive recommended practice offers high-level administrative guidance for establishing a scheme and addressing the fundamental requirements of a dropped object prevention strategy across every step. Take the time to realistically identify and assess dropped object hazards. This may be the opportunity to eliminate or substitute, change the hazards. All controls must be authorized and verified. Ensure these are being managed throughout the task planning and execution. Ensure there is opportunity to talk about dropped object potential during pre-lift toolbox talks to reaffirm how they might occur and what controls are in place and who will be responsible for them at each step. Pre-lift equipment inspections may follow a set checklist or picture book, but all personnel should be familiar with the concept of reliable securing, a great resource available from drops and a key part of a dropped object prevention management system. As the lift is executed, there's need for constant vigilance in ensuring that access to areas within the cone of exposure remain restricted and that any critical equipment is protected where practical. And once the lift is completed, there are specific tasks to undertake, but also ensure that any damage sustained to equipment or damage to loads is inspected, recorded, and prioritized for corrective action. Then exploit industry resources designed to support after-action reviews. Walk through and talk through the task to determine what went well and what could be improved. Returning to reliable securing, this is a fantastic document that contains relevant and readily adaptable guidance for the securing of structures, equipment, and tools at the worksite, particularly where it was secured at height. A section covering bolting best practice, a simple guide to the various types of fastening methods found on equipment, provides basic awareness of the key principles of drops. Confirm and verify the primary method of fastening, the bolted joint, the clamp, the pin, the hinge, the strap, and make sure it's authorized and is per OEM, Original Equipment Manufacturer Recommendations. Consider how this might be affected by external forces such as vibration, loading, etc., and identify with the secondary retention device, the locking nut, the locking washer, the lock wire, split pin or safety pin, and understand how this is supposed to perform, and assess the requirements for additional safety securing, such as nets and wires and slings and tethers and lanyards. Confirm that these are correctly fastened to items and back to the structure, and exploit the pages as overview guides or training and familiarization aids that illustrate a variety of common engineered methods for securing. Explore how each fastening and fixing functions and appreciate what to look for in equipment inspections and confirmations at each task step. Where personnel are required to work on cranes at height, adopt the best practices illustrated in drops guidance. Eliminate unnecessary and loose items. Select tools suitable for use at height. Consider bespoke mobile toolkits that contain only the tools required for the equipment. Create inventories, track and trace tools and equipment aloft with logbooks, and ensure 100% tie-off principles are observed from the time the items leave ground level to when they are returned. Within the booklet, there are many examples of worksite inspection prompts and checks, including pre-lift cargo inspections. Whilst there may be generic checklists, consider how each individual item presents its own unique challenges. Drops backloading supports this in more detail, with pictorial references presenting key areas to inspect, beyond the obvious checks for loose items or debris in forklift pockets. Adopt the best practices in sharing responsibilities and being accountable for the final checks, particularly when the lift involves the onward transportation of cargo. And then the 10 questions for a safe lift may be a common prompt, but it is the last step prior to performing the lift, and it's a critical component in confirming and in verifying that all elements of the lift plan, including all securing and safety devices, are in place and functioning correctly, and that the restricted lift area is controlled and clear. In fact, there's a wide range of free to download material available through the DROPS website, from awareness campaigning posters to guidance on establishing management systems and systematic equipment and worksite inspections. The consequence calculator is available in both posterized and functioning Excel format, along with an exclusion zone calculator that can help determine deflection trajectories. Simply enter the height of the object and the deflection point above the ground, and then use the slide bar to alter the deflection point. It's a great awareness tool, refocusing the task plan to ensure that all aspects of the hierarchy of control have been studied, opportunities for elimination exhausted, opportunities for substitution sampled, and all engineered and administrative controls confirmed and corroborated. There are many other resources available through industry, particularly online, but for dropped object prevention in particular, and with reference to lifting and lifting equipment, I believe you'll find these useful and adaptable. If you do work in the wind energy sector, you will be interested to see an example of DROPS guidance readily adapted for your industry. So what can we do to prevent dropped objects? Well, respect gravity. It's not quite like other hazards. It cannot be removed. It can't be switched off, and it can't be isolated. We must identify the potential for dropped objects in every task step. We must do more than just eliminate the loose and unnecessary items. We must be prepared to walk through each task step and consider how gravity and other forces will affect the lift, and ensure that all controls are installed and verified. The OEM recommendations should always be followed. And with a greater understanding of how fastenings function, we can question their robustness, particularly where they may become snagged or exposed to contact with structure or another piece of equipment. Sharing best practice and lessons learned is ultimately how we've all developed and implemented safe working practices. But with dropped objects, we must always be vigilant, because dropped objects can occur anywhere and at any time. So get involved, explore DROPS resources, share it with your colleagues, and help to make a difference. So thank you for watching. Thank you for supporting the LIA Global Lifting Awareness Day, and enjoy exploring the variety of presentations and events on offer. I wish you every success and a future free from dropped objects. Thank you.